We call them as process performance indices. Earlier, you already learned CP and CPK. How do we call them? We call them as
Process capability
process
indices.
capability indices. Now, this particular session is to understand the difference between CP, CPK and PP and PPK. So CP and CPK refers to capability, but PP and PPK refers to performance. How many of you can sing well here? None of you. So how many of you can dance well? So if you have the dancing, yeah, madam can dance well. So she is capable of dancing. But if she has to perform now, let's say if she has to perform in front of 5,000 people. So we all know she is capable of dancing, but then now what is the requirement? Dance to a crowd of 5,000 people. And now it is not that easy, isn't it? Like dancing regularly. Now it's a forum with 5,000 plus people audience, and now the performance really matters, isn't it? If people are afraid of seeing the audience, then performance can be bad. In spite of having a better capability, somebody could perform badly. Possible or not? So what people feel or what the customer feels from your process is known as performance. So performance is what the customer actually receives. Capability is what are you capable of? Which is important in business? Capability is important or performance is important?
Both.
Performance
Both.
and capability both.
Both.
Both are important. Very good. Both are important. If you could match them, you are the best manager in your company. If you develop a process which not only has the capability but also can perform, you have fantastic control over your process. Am I right?
Yes, sir.
You develop the process with the higher capability. CP, CPK are great. After 1 month, after 3 months, after 6 months, after 3 years, you are able to retain the capability and also retain the performance. How? Through very effective process control. Yes or no? If we conduct the exam this week itself, the chances of passing the exam is more. Am I right? Because you recently studied everything. If I keep the exam after 3 months, now your marks are expected to step down, isn't it? So performance. Why performance is going down? You had a poor control over your learning, isn't it? You learn only when somebody is pushing you. Otherwise, you stop learning. You don't refer to your notes and everything, isn't it? But if you continue maintaining the control, then what will happen? Even after 3 months, you can score a high marks. Do you understand? So the requirement is performance should be up to the capability. In an ideal scenario, PP, PPK will be exactly equal to CP, CPK. If you are a consultant, if you are going for an assessment, audit, if a company maintains a PP, PPK and a CP, CPK exactly closer to each other, you can understand they have effective control in place. Isn't it? And if both of them are acceptable, PP, PPK as well as CP, CPK, you should give them a good marks as an auditor. Do you understand? If you go to a company as an auditor and PP, PPK is not great, but CP, CPK are great. Now, what is your understanding now?
It will deteriorate over the period of time. The
Yeah,
capability will.
they have the tendency to lose the control over a period of time. And how much is the period of time? You need to assess further. If whenever you see a significant difference in the performance from a previous state to other state, now you get an idea about the period. Some people lose the control in 1 month time. Some people lose the control in 3 months time. Some people lose the control within the week. We don't know. By getting into the details of the data, you can understand. Clear, all of you? Now another scenario: you go for an audit to one of your supplier. Their PP PPK is unacceptable. CP CPK also unacceptable. Now what will you do?
Stop the production.
Hmm?
Stop the production.
Stop the production. You must better Uh, you must suggest for probably canceling the
Establish the
relationship. Yeah, you should not allow them to produce unless and until they improve on both CPCPK and PPPPK. Suppose if CPCPK is okay, but not PPPPK, that means what?
Then we will advise for the controls to better
Yeah.
controls.
Yeah, you need, yes, exactly. You should advise for the control features. How do you control all the, input, I mean, incoming quality material, how do you control the raw material quality? How do you control the, operator skill and everything, the machine condition, all of these things, you must demand. And if they also support, then probably, there is a good chance that they could supply you good products. Okay. So if CPCPK is good and PPPPK are not good, it simply means they are okay as far as the short current requirements are concerned. But definitely they seem to be in problem for a long-term requirement. You understand? So that is the thing. Now, how do we actually calculate CPCPK and PPPPK? We calculate both CPCPK and PPPPK using sample data. Using sample data. And like RK was saying, always, make sure you work with a large sample. Large sample means sample size of more than
30.
30.
30.
So that is always advisable because more the data, better will be the prediction. More the data, better will be the prediction. But both CPCPK and PPPPK, both of them are calculated using the sample data only. But what is important? The period of data collection is very, very important. What is important? Period of data collection. You can collect the data in a single day, or you can collect the data spreading over a week. Which is better?
Spreading over week.
Okay. You can also collect the data by spreading your data collection over a month. Over a week is better or over a month is better?
Month.
Over a month is better. And you are very, very confident that studying it for more than 30 days time is not required. That means whenever possible, go for state data collection over 30 days. But suppose if situation is not allowing you, you only have 2 weeks time. Within 2 weeks, you have to prepare a report. And now you can't wait for 30 days, isn't it? Because after 15 days, the audit is coming. And now you have only option of studying only for 15 days. In this condition, what should you do? What should you do? You have 15 days only, isn't it? Like, for
We will
example, next week you have exam. You only have 6 days.
Daily average.
Yeah. And now, within the 15 days time, probably if needed, you increase the frequency of data collection. Let's say earlier, you normally used to collect, data once per shift. Now, instead of that, you go for data once per 4 hours. Do you understand? So somehow, if the period of data collection is limited with the prevailing conditions, the only option you can have is probably you can increase the frequency of data collection. Suppose if only 1 week is available, you within the 1 week you study, but you try your best to capture as much information as possible. Clear, all of you? This is how you must plan the data collection. Now, after collecting the data, now you have some set of data. You can use the data into to calculate the uncertainty. There are two types of uncertainty. One is short-term uncertainty, another one is long-term uncertainty. One is short-term uncertainty, another one is long-term uncertainty. With the same data, you can calculate both form of uncertainty. And uncertainty means we calculate standard deviation. Uncertainty means we calculate standard deviation. So we have two types of standard deviation. One is short-term standard deviation, another one is long-term standard deviation. If I use the short-term standard deviation, then the metric I get will be CP and CPK. Then the metric I get will be CP and CPK. If I use long-term standard deviation, then the metric I will get will be PP and PPK. Clear? Now you just have to understand what is the formula for short-term standard deviation and what is the formula for long-term standard deviation. That's all. Now you are a master of CP/CPK as well as PP/PPK. So what I do is I quickly take you through my slides where you will recap the CP/CPK also as well as the PP/PPK also, right? And yeah. So CP/CPK and PP/PPK. So straight away, I'm giving you the formula for CP/CPK. Can you see here? What is the formula? One of you tell me. What is the formula for short-term standard deviation? You see here?
Yes, sir.
What is the formula?
SL minus LS divided by 600.
6 sigma.
Huh.
Standard
Uh,
6
deviation.
sigma. That is the formula for CP. Formula for standard deviation is written here. Can you see in red color?
R bar divided by
R
D2.
bar divided by D2. This is known as within. Within means short term. If you can do anything within today, that's a short term, isn't it? So within means short term. So within standard deviation, if you are using within standard deviation, then your formulas can give only CP and CPK. Now, look at my process. And now, is this process capable? Control limits inside the specification limit. Is it capable?
Yes, yes.
Yes.
Yes, capable. When I calculate CP value, that is 1.67. And now control limit has gone outside the specification limit. Can you see? Now process is not capable. In this scenario, CP will fall below 1. And now process is capable. Why it is capable? Control limit inside the spec. But now what happened?
Not capable.
Because the process has got shifted. Can you see here? The process shifting to the right side. Now, even in this scenario, CP still gives 1.67. Since CP is healthier, it doesn't mean your process is capable. You should understand the position of your process. You should understand the position of your control limit. If my process is shifting, my control limit is also shifting. So CP cannot be an accurate measure of capability. Please note. CP is only potential measure of capability. What is the name of CP? Potential measure of capability. It is not an accurate measure of capability. So in order to measure accurately, we introduce another metric which is known as CPK. Here in my slide right now, I'm still showing you CP only. CP with the control limit overlapping specification limit. So what is the value of CP I'm getting? 1. When CP equal to 1, the process is known as 3 sigma process. When CP, when CP CPK are equal to 2, process will be 6 sigma process. Why do I call it 3 sigma process? Can somebody answer? Why do I call it?
Because
1
control
point-
limits and specific limit are lying with 3 standard deviation right and left.
Very good. Because both my control limit and specification limits are overlapping. In that scenario, the distance between the center of the process and the nearest specification will be equal to 3 times standard deviation. Imagine this upper spec, this upper spec and this lower spec represent the size of the door. Represents the size of the door in your house. All right? And imagine the a person want to enter through the road. Sorry, enter through the door. A person want to enter through the door. And now he must be leaner than the door. Yes or no?
Yes.
Yes.
If he is bigger in size than the door, he can't enter. And now we are going to represent the size of the person in terms of standard deviation. In terms of standard deviation. Let us say the width of the person or the size of the person is equal to 1 standard deviation. What is the width? 1 standard deviation. Now, how many standard deviations are here?
3.
3 standard, which means to the right of the center of the door, 3 members can at a time enter through the door. Can you understand? Similarly, 3 more members can enter through the left side portion of the door. So at a time, how many people can comfortably enter through the door? 6 people.
6.
And now the process is 3 sigma process. Even though 6 people can enter, 3 on the right, 3 on the left. So we call the process as 3 sigma process. All of you understand?
Yeah.
If people become much more leaner, now more than 3 people can enter on either side of the door, isn't it? If 6 people can enter through the right and another 6 people can enter through the left, that means at a time 12 people can enter through the door. Now the process is 6 sigma process. All right. So when I say percent, I refer to 1 standard deviation. Your process standard deviation talks about size of your process. Clear? Okay. So now the now it is it is about CPK. When it comes to CPK, what we do is we check whether our process is shifting to the right side or left side. When the process is not at all shifted, CP and CPK will give the same value. But when the process is shifted, you can see process is not shifted. Now CPK is found to be 1.67. CP will also be 1.67. But when my process is shifted, CP will still remain at the same value, but CPK will drop. Can you see here? CPK. CPK means minimum of CP upper or CP lower. CP upper means the formula you have. USL minus X bar by 3 sigma. CP lower means X bar minus LSL by 3 sigma. So I get 2 different values for CPK. When you have 2 different values, you have to choose the minimum. Which is the minimum here? 0.8. So CPK is 0.8. Clearly confirming that process is not capable in the long term. I mean, process is not capable according to the data, even in the short term. So CPK gives a realistic estimate of the capability, not the CP. CP fails to detect the shifting of the process, but CPK can even capture the shifting of the process. All of you, do you understand why we need CPK? CPK measures the spread of the process and also the shift of the process. All right. So the conditions to be fulfilled. First of all, this is the condition. CPK must be more than 1.67. If CPK is more than 1.67, you can declare the process to be capable. All right. And if CP is more than 1.67, don't declare the capability without looking at CPK. Then what can you do with CP? What you can say with CP is you can declare that your process is stable or consistent. If CP is more than 1.67, your process is under statistical control. Your process is consistent. Your process is stable. You can use all these words: stable, consistent, statistical control. But in order to use the word capable, CPK must be more than 1.67. If you have very good control, then you know what will happen. You will see that CP equal to CPK. In an ideal scenario, your actual capability will be equal to the potential capability. So you can always aim for fulfilling this condition. What is this condition? CP can be equal to CPK. If you look at, suppose if it happens to refer to a CPK value, CP equal to 1.87 and CPK equal to 1.37. What is your understanding now? CP equal to 1.87, but CPK equal to 1.37. Can you see a difference of 0.5?
The variation in the readings are low, but from the mean, it is more.
Very good. Process is shifted. Now you can certainly advise your team member to further improve the process. Further improve. There is some special cause which you can easily detect. When the process is shifted, you can easily, the investigation is little easier compared to detecting the reason for the spread. So you can expect your team to improve the performance further because definitely CPK can be brought closer to CP. Right? That's the idea. And now some calculation example. You see this is upper spec and lower spec are given. It is an electronic manufacturing company. Current flow specifications are given 100 plus or minus 10. So upper spec is 110, lower spec is 90. And the process average process standard deviation are available. And that leads to CP of 2.22. But for the same data, CPK is, I get 2 value. Which one I should choose? The smaller one. So 0.66 is the CPK. That means my process is capable or not capable?
Not capable.
Not capable. and CP is not equal to CPK. So that means my process is shifted. So action required is I should shift the process average towards the target. And when I look at my CP is looking great. No action is required with respect to the variation. Process is under perfect control. But only thing is it is shifted. All right. And finally, I look at CPK, which is very poor. So what action I need? I refer to the previous understanding. So I know that no action is required with respect to CP. So what action is required? I should only have to move the process mean towards the target. But how can you move the process mean? You have to figure out. Suppose imagine our students' average marks is standard is 80, but you all happen to achieve an average of only 65. What happened to my process mean? Shifted downwards. Am I right? Now I want to move the average towards the target of 80. Now what should I do? What should I do? I want all of you to score more. Then only my average can move up, isn't it? Now what should I do? I should increase the number of hours of the set classes. Probably the exam, mock exams, I should give more mock exam. Yes or no? So all these things can definitely push my average. So what needs to be done at your place, you need to understand. Now another scenario, I'm not going to read out this, and CP equal to 1.11 and CPK equal to 0.666. Now what is your understanding? Both are under trouble now. What should I do? I should move the mean and also reduce variation. Very good. So now what is your recommendation now as a consultant, as an expert? CP equal to 0.94, CPK equal to 0.33. What is the suggestion, recommendation?
Process is not capable. We should reduce the variation. Also move all the readings near the mean.
Yeah, move the mean towards the target. Very good. So you know everything about CP and CPK. Now we just move on to PP and PPK. I'm showing two different cricket players. One is Shikhar Dhawan, the other one is Sourav Ganguly. Both are left-hand batsmen. Both could hit well. But then if you really want one of them to play for India, whom you will prefer? You will prefer Shikhar Dhawan or you will prefer Sourav Ganguly?
Shikhar.
It's
Yeah,
difficult.
if tomorrow's match is very important, Shikhar Dhawan's is the right choice. Why? Because he is not only capable of hitting, his physical fitness is also now good. Yes or no? In addition to the capability, past record, his current fitness is also important. So PP and PPK measures the current fitness also. Please understand. Okay. And now for PP and PPK, look at the formula. Formula wise same. Can you see? USL minus LSL by 6 sigma. That is the formula for PP. Again, similar to CPK. For PPK also you have PP upper, PP lower. What is the difference? The way we calculate the standard deviation is the difference. There is earlier, what was the formula I have given you for CP? Within standard deviation, R bar divided by D2. Do you remember that?
Yeah.
But now I don't want you to use R bar by D2. I'll tell you what is R bar and everything. But now you should use this, which is known as overall standard deviation. Whenever you use overall standard deviation, you get PP, PPK. Whenever you use within standard deviation, you get CP and CPK. And now the capability definitely depends on two things: the position of the center of the process and the variation in the process. So based on this, there are two types of capability. One is short-term capability, the other one is long-term capability. How can I calculate short-term capability? Using within standard deviation. How can I calculate long-term capability? Using overall standard deviation. Within the short term, we have some different standard deviation. I don't want to confuse you with too much information. So focus on within, understanding the within and understanding the overall. Later, we'll talk about these two, preferably at the MBB level. So now if you use within standard deviation, you get within capability. This is what normally referred as CP and CPK. If you use overall standard deviation, you get overall capability. This is what we normally refer as PP and PPK. The performance indices are here on the right side. The capability indices are here on the left side. Sometimes we call CP, CPK as short-term measures and PP, PPK as actual or long-term measures. Now is the formula. Now we are going to look at a case study. And prior to that, please note, whenever you want to conduct a capability study, make sure your process is under the state of statistical control. Then only it is advisable to conduct the capability study. What is the requirement I'm telling you? If you want to calculate CP/CPK and PP/PPK, the prerequisite is your process must be under the state of statistical control, which means if you plot a control chart, all the points should appear inside the control limit. If that is not happening, conducting capability study cannot be accurate.
Within
Imagine a
USL and LSL.
No. Control limit. In control chart, we refer to only control limit. No USL, LSL. So if in the control limit, if all points fall inside control limit, then your CP/CPK and PP/PPK can be accurate. Otherwise, they will be inaccurate. What are you going to do with inaccurate CP/CPK and PP/PPK? Useless. So don't fall into that situation. Always check whether control chart is healthier. If control chart is healthier, conduct a capability study. Imagine right now how many people are attending the meeting? It shows 21, isn't it?
Yes.
And the batch size is somewhere around 35. Now, how many people are absent?
14.
Now tell me, do you want to allow the 14 candidates also write the exam? Do you want me to allow the remaining 14 candidates also to write the exam? Strictly speaking, should we allow or should not we allow?
Yes, they can follow
Strictly not
recordings.
allowed, no?
Yeah, strictly we should not allow. Because they have not attended the class. They are not in proper control. Isn't it? And in such a situation, assessing their performance is meaningless. Yes or no?
Yes,
What do you come to know as a teacher by referring to their marks? They have not attended your class. It's no way going to reflect, the quality of the training. Yes or no?
yes.
So similarly, when your process is statistically out of control, you still calculate CP and CPK on PP and PPK, they will become inaccurate. How many of you want to use inaccurate reports?
No.
But we do that in business. I don't know the reason. We do that, isn't it? So please avoid hereafter. Hereafter, don't refer to inaccurate reports. Look for, accurate reports. So if you want accurate report, what should you do? Have a good control over the process. Have a good control over the process. Then look at the CP/CPK, PP/PPK. They will be accurate estimates. They will give your, realistic capability and realistic performance. All of you understand my suggestion? Do you agree with me?
Yes, sir.
Yes.
Very good. Fantastic. You are really going through the transformation now. So if process is in statistical control, then only you must conduct the capability analysis. And if you want to know your short-term capability, look at CP/CPK. If you want to know your long-term capability, look at PP/PPK. Always expect CP/CPK and PP/PPK to be close to each other. Clear?
Okay, sir.
No shift.
Very good. Very good. Suppose, imagine.
Sorry, sir.
Yes. Any question?
Yes, sir. Sorry, was doubt, sir. For example, for CP/CPK, if you have an issue, for example, if out of LSL or USL, then that will be one of the defect or concern, right, sir? Then it should not
Yeah,
be
out
comes
of-
to calculate CP/CPK.
Yeah, see, out of LSL, USL means definitely that's a defective part.
Correct. In
Correct?
that case, how we will, for example, other quality tools we have to bring down within the LSL and OSL, then we have to go for a process capability study, or how it will be, sir, generally.
See, that is why to avoid this scenario only, I gave you a suggestion. Please ensure your process is under the state of statistical control first. What is statistical control? Points are inside control limit. But you are talking about
Okay.
specification limit. Are you following me? You are
Correct.
talking about specification limit, but I am
Correct,
talking
correct,
about
correct.
control limit.
Yes.
And we are talking about CP/CPK value of
Okay.
1.67, isn't it?
Correct.
We are talking about CP/CPK value of 1.67. That means our control limits are always expected to be inside the specification limit. Do you got this point? Do you get this point?
Correct. I can able. Yes, yes.
Very good.
Yes, yes,
So,
yes, sir, I can able.
if you see a point going outside the specification limit, well ahead of this time, you must have seen a point going outside the control limit. Am I correct or not?
Correct.
Yeah.
That means you have a poor control over the process.
Correct.
That is why you are facing the consequence of seeing a higher PPM in your shop floor. You
Correct.
get my point? So please
Sir, could
be
you please go over the
proactive.
Yes, sir,
last
yes, sir.
point again? Your voice
Can I
was
add? Can I
not
add?
clear.
Sendayan, did I explain it fully? You are able to get it fully?
Yes, yes.
What I was saying
Yes,
is,
actually,
don't wait
small.
for...
Yes.
Yes, please. Go ahead. You are saying
Yes, sir.
something. Go
In
ahead.
that case, yes, in that case, my doubt, it should not be the capability analysis. With other tools, we have to bring down into UCL and LCL. They have to go for
UCL,
this
LCL.
estimation.
Very
Sir.
good.
This is my
Very
doubt.
good. You understood. I want
Okay.
you to be more proactive than reactive. If you wait till your part goes beyond the spec, you are reactive. If you take action by the time your point goes outside the control limit, now you are proactive. And always ensure your control limits are inside the specification limit. Customer will not have any chance of seeing a defective product.
Sir,
Clear?
can I comment?
Yeah, okay. Okay.
Yes,
Okay.
please.
I clear.
Can I add, sir, here?
Oh, yes.
Please note, my wife is wanting me to buy vegetables, right? And then my wife comes along with me to teach me how to buy vegetables. The vegetables are rotten. I pick up rotten vegetables. What my wife will do? Tell me. I pick up rotten vegetables. What my wife will do? Tell me, sir.
Probably
She will
might
not provide dinner.
Reject vegetables for some time and then outrightly reject me also. Right? If you are not married, right? Reject me also. Nowadays, even that's possible. So this is called rejection. This is called specification limits. Agree? Understood?
Okay.
Specification limits come into picture only for rejection. Outrightly rejected. So what the vegetable vendor looks at this happenings, reality. He is a soft man, yeah. He is also a male member. No, he's not a lady. So he has a soft corner for RK. Therefore, he wants to be careful. And then he tells his son to buy all fresh vegetables. So he is buying from next day onwards, he's buying fresh vegetables. Now I take my wife and then going there. I am picking up the vegetables. Right? All are okay. Not very rotten. Some rotten, some not rotten. It's okay. Now I am taking the vegetables. Now, will my wife reject me or will just give me advice? She will give me advice.
Advice.
Very good. Very good. Don't select that, select this and all. Right? Yes or no? Because there is no chance of my getting a rotten vegetable because rotten vegetables are not there. Rotten vegetables are not there in the with the vendor. Therefore, there is a good control from the process. The vendor has got good vegetables so that I will never be dissatisfied with my wife. Because my wife is never dissatisfied with me. Because I will never get a rotten vegetable from there. Now you got, this is, tell me, this is CP/CPK or USL LSL?
CP/CPK.
CP/CPK. Very good. Now, what happens, now that I gain knowledge, how to influence my wife, I know. Then I look for other vendors. There is another vendor who is getting fresh vegetables, yeah, looks green. Then I took my wife, hey, Rukmini, I come with me, I will buy from there, I know how to buy. So I go there and buy it. Now all the vegetables are fresh, much fresher than the previous one.
Receive a lot of appreciation now.
Will I get a good name from my wife? My wife will keep me for lifelong. Yes or no? Now
Yes, sir.
tell me, this vegetable vendor, PPPPK or CP/CPK?
PPC.
CPK.
PPPK. Because for
Oh,
even after
PPPK.
4 days, I can go there, fresh vegetables, I will, without any doubt, I can buy. This is what the difference between specification limits,
Excellent.
CPCPK and PPPK. Thank you very much.
Excellent example. Even though every part is accepted, you still look for best out of the best, isn't it? If you aim for further best, you will not only improve CPCPK, you will also improve PPPK. So don't try to minimize talking about upper spec and lower spec. Rather, talk in terms of upper control limit and lower control limit. If you achieve that, try to push your control limit further towards the center. Now you are getting very, very green vegetables. Now you are there in the agri field itself. You are buying directly from the farmers now. Do you understand? Your control limit going closer to the center, and your center moving towards the target. That means one day you will see you growing your vegetables on your own. You have your own farm now.
Can I come,
You're
sir?
not giving anyone to play with your food. You have very strong control over the process. You are now capable not only in short term but also in long term. Right? Nothing can affect you. No ups and downs in the price because you are making your own food. You can manage well.
Sir, can I come? Just 1 second, sir. Just 1 second. Just one sentence. Very, very important. In fact, Gopal Shukma was very right because I always want to pull him. It doesn't matter, no problem. This he said correctly, no? I get a good name, right? And this is a real life, yeah. Today also I went there. But the thing is, the problem with this is I have to walk a mile long to get from the farm. Right? I go there near the beach, no? There everybody, every day it comes. So I go a mile walk I have to do and get that to maintain that PPPK. What does this convey? You have to work hard. Just like that process will not give you PPPK. CPCPK to PPPK is like getting from 80 marks to 90 marks. So hard work is essential. Our aim is to have a PPPK very high. Thank you very much, sir. Thank you very much for this.
All of you understand, right?
Yeah.
If you are having the habit of scoring above 90, absolutely you don't have a chance of failing at all. That's the point. We are not talking about passing and failing. We are now talking about the toppers. Whether I can be a topper or not. We never fall into the category of passing or failing. Now, one case study here. See, a company has to produce parts. The process is coating. They have to coat. A layer of coating is required. And after coating, the coating thickness must be 50 microns. What is the target? 50 microns. And customer gives a specification. Plus or minus 3. 50 plus or minus 3 microns. Very narrow spec. Now, what is the upper spec now?
53.
53.
Lower spec is 47.
47.
Now, you have to have a very, very, very effective level of control so that, your products can always stay inside the specification. All right. So now you are collecting data. See here how the manufacturing is happening. The raw material comes in the form of a roll. Raw material comes in the form of a roll. Once a particular roll is loaded, you are able to produce 5,000 parts. One roll can give you how many parts? 5,000 parts. Once the roll is exhausted, now you have to load another roll, roll number 2. Can you see the roll number keep on changing? 1 to 2, 2 to 3, 3 to 4. And then that means you consumed 25 rolls. Totally, how many parts you produce now? 25 into?
5,000.
So totally, how many parts? 1 lakh?
5,000.
25,000 parts you produced. Now, in this scenario, you want to know your CPCPK and PPPK. Clear? So now, please note your data collection plan. Now, loading 25 rolls, how much time it might take, isn't it? Imagine. And now, 25 rolls were processed. This is a considerably good period of time. Your data is collected. From every roll, you have taken 3 samples. Can you see here? Every roll, you have taken a 3 sample. The 3 samples taken together from every roll is known as subgroup. So 25 rows, you have 25 subgroups of data. Each subgroup has got 3 samples. The 3 is known as subgroup size. Totally, you have 75 data. The 75 samples represents 125,000 parts. Isn't it? If there is a problem with the 75 parts, if there is a problem with the 75 samples, there is a big problem with 125,000 parts. Am I right?
Yes.
If there is a problem with the average of the 75 data, definitely there is going to be customer complaints in the 125,000 parts. So the overall average is very crucial for you. All of you agree with me?
Yes, sir.
Subgroup number 1, first subgroup. First, there is a problem with the first subgroup. First 5,000 parts are in trouble. Am I right?
Yeah.
So you need to understand 2 things. One is the center value. If you consider all 75 together, what is the overall average? That will talk about all 125,000 parts, the quality of all 125,000 parts. All of you agree with me? If you calculate overall standard deviation, what is overall standard deviation? You calculate the standard deviation for all 75 data at a time. If you are not happy with the standard deviation, that means there is going to be a problem with 125,000 parts. Majority of the 125,000 can have defective pieces. That depends on the actual magnitude of the standard deviation. All of you understand? If you want to take a focused interpretation, let's say first 5,000, what happened? Then I will look at first subgroup only. The first subgroup will have an average. Yes or no? First subgroup will have an average. First subgroup is also having some variation inside. Can you see that?
Yes.
The variation inside the subgroup is known as within variation. Within variation can help you to understand the quality of 5,000 parts. But overall variation can help you to understand the quality of 125,000 parts together. 125,000 put together, what could be the problem? Your overall standard deviation can speak. Overall average can speak. Am I right? What is the problem with the first 5,000? First subgroup average. First is the variation inside the first subgroup. That can speak about the quality of the 5,000 parts. Our expectation is average should be on the target. What is your target? 50 microns. Your target is 50 micron. Any average moving away from 50, is it good for you?
No.
No.
No. Expect all the averages, expect all subgroup averages to be on the target. If all subgroup averages are on the target, then overall average will definitely be on the target. Am I right?
Yes.
Yeah.
And moreover, if you look at the subgroup, you only have 3 data. Please note, you don't have much. When you have lesser number of data in the control chart itself, we have taught you. When the number of samples are less than 8, you are going for X bar R chart. Am I right? Same manner, in order to understand the variation, calculate range, not standard deviation. After calculating range, you can convert the range into standard deviation. All of you are with me so far? And the formula that is used to convert the range into standard deviation is R bar divided by D2. What is the formula?
R bar
divided by D2.
That's all. With this, we are now proceeding with the calculation. Number of subgroups equal to 25. Subgroup size equal to 3. Total number of data, 25 into 3, 75. Now for every subgroup, I want you to calculate the range. Formula for range is maximum minus minimum. How many ranges are possible? 25 ranges are possible. Am I right?
Yeah.
Yes, sir.
This is known as subgroup range. With the 25 ranges, can you find out R bar by D2? What is the formula? R bar is summation of all the ranges divided by 25. Can you do this? Simple, no?
Yes, sir.
Now R bar is available. Now what is D2? D2 is a statistical constant. A table is available. For a subgroup size of 3, The value of D2 is tabulated as how much?
1.693.
1.693. Up to a subgroup size of 25, D2 is available. You don't have to worry. Right? Even though people say no, go for a sample size of 30, the normal practice is up to 25 only, and that is tabulated. Now use this 1.693 to convert your ranges into standard deviation. Now the resulting standard deviation is known as within standard deviation. All of you understand how to calculate within standard deviation?
Yes.
The within standard deviation actually talks about what is happening inside the subgroup. Clear? Now, if you use this within standard deviation, you will get CP and CPK. Look at your CP, CPK. You all know the formula. What is the formula for CP? USL minus LSL divided by 6 times sigma. But in the place of sigma, which value I should substitute now? 0.4139. Substitute 0.4139. I will get a CP value of 2.46, CPK value of 2.37. Extremely healthier. Am I right?
Yes, sir.
No rejections. I can't see any rejections out of this, in each of the 5,000 parts, there is no rejection at all. Every 5,000 parts comes with no rejection. How many of you agree with my statement?
I agree, sir.
Right? Because, I have a very good CP-CPK value. Very good. And now I want you to calculate overall standard deviation. If you want to calculate overall standard deviation, how many data points you have? 75 data points. Simply type all the 75 in an Excel, single column. Calculate the standard deviation. And now look at the standard deviation. How much it is?
0.8384.
In comparison to the within standard deviation, can you see what happened? 0.4139 has now become 0.8384. Can you see what happened to the standard deviation, overall standard deviation? Can you see this getting doubled?
Yeah.
Yes, increased.
Currently, with the 25 rows, nothing wrong happened. But if you continue the production in the future, there will be lot of rejections that is going to happen. This sigma is giving a warning. Do you understand? Why do I say current production is okay? Because CP-CPK is all healthier. Right now, no problem with the units I produced. No rejections. It doesn't mean that in the future also no rejection. In the future, rejection can come. Yes or no? What is the chance for rejections to increase in the future? The chances are very high. I could sense that, like how we predict a tsunami, same manner, whether the rejections are likely going to be higher in the future. I sense that by looking at the overall standard deviation. If instead of using this within, if I use the overall, my CP-CPK metric will now be called as PP-PPK. Look at your PP-PPK now. What happened? 1.19 and 1.15. What is the standard required?
1.16.
1.67. That means you seem to have good control in the short term. But this is not enough to retain your capability in the long term. Do you understand? Right now you are doing well. It doesn't mean that you will always do well. Right? Right now you are doing well, but we want you to do extremely well so that in the future also you will remain well. Do you understand? We don't have any health issue right now. But we want to remain in the same condition even at the age of 80s and 90s. Now we have to improve a lot. Can you understand? That is the message coming here. Now PP-PPK, you know how to calculate PP-PPK. You also know how to calculate CP-CPK. Clear? Now imagine you are going for an audit to one of your supplier. Will you demand for a PP-PPK or demand for a CP-CPK?
PPPK.
Both.
PPPK.
Both. But please note, if you demand PP-PPK, your demand for CP-CPK is taken care. If you are planning for a healthy life at your 80s and 90s, you are already healthy now. Isn't it?
Yeah. Yes.
So when you are going for auditing one of your supplier, demand for a PP and PPK. That's why many of your clients are asking you PP, PPK report. Am I right? But you just want to know your current capability. Which metric you should look at now? Because you are now going to deal with an item which you will produce only for 3 days.
Then
You want
CPC.
you produce
CPK,
3 days.
CPK.
Now CPK is all good, isn't it? Because you are just going to produce the part only for how many days?
3 days.
weeks.
3 days. The requirement itself is short term. Now, having a CPK itself is all good. You don't have to really worry about PPK simply because your requirement is for short term only. Clear? So, you please decide what is your requirement and accordingly have a choice. But it is always good to achieve a higher PPK because CPK will be automatically taken care. Now, if there are any questions, you can ask. And see here, I am showing you a process. Now tell me, is this process under state of statistical control? Are you happy with the control chart?
No.
No.
First one, no.
First one,
Second
no.
one, okay.
Second one is within
Please note,
50%. Na?
we always need 2 control charts. 2 things to understand, to comment about any process. One is central tendency, another one is variation. Both of them represent single process only. This represents process spread. This represents process center. Center is frequently shifting, both upward and downward. Can you see that? The
Yeah.
process is highly unstable. Now, will you conduct capability study? You are not supposed to, isn't it? According to the understanding now, you are not supposed to conduct the capability study. Why? They are not going to be accurate. They will be inaccurate, isn't it?
Yeah.
They will be inaccurate. And so what do you do? Well, what normally people do, they remove all the red color points. Yes or no? They remove all the red color points. But what happened actually? There are red color points. Are you doing the analysis in the right way? No. You are making, a mistake, isn't it? So you must add a statement when you do that. The statement must be assumption. What is the assumption? There are no outliers in the process. The red color points are known as what? Outliers. So your analysis is valid only if the outliers are arrested. Otherwise, your readings are inaccurate. All of you, do you understand? If you are in a scenario, if your boss is pushing you to calculate CPK, when your process is out of control, at least you must add a remark. What is the remark? There are no processes. I assume process is believed to be, even you don't have to say assumption, you have to say the process is believed to be under statistical control.
Understand.
You believe, but what is real, God only knows. Right? Do you understand the meaning of adding the remark?
Yeah.
You are indirectly saying that your report is inaccurate. Correct? The person who knows the subject, they will understand from the remarks. Person who don't know the subject, they will not read your remarks. Yes or no?
Yes.
So adding the remark at least makes your report, ethical. Correct? Am I right? Okay. So that's it from me on PPPK. If the process is statistically out of control, should we do CPCPK study or PPPK study? We should not do both, because both of them will come out to be inaccurate only. That's the message. And now this is the Minitab report for the same set of data you see here. 1.19, 1.15, 2.46, 2.27. Everything we did it manually and we got the exact result. A process that is operating in this manner currently, you see a good control. Can you see here? Good control, the dotted line. But in the long run, gradually it is stretching outwards. The control limits are moving outwards. And that's the red color one. Red color one represents long-term performance. The dotted line represents short-term performance. Both of them more or less inside the spec only. But the tendency to cross the LSL on the left side is very high. And that's why, you see the PPM of 393 is expected. You see here. Currently, PPM is how much? 0. Because of higher CPR. But in the future, ppm is expected to be 393. If you can't tolerate this 393, you must establish better control. Bring additional control in the process so that you can avoid the 393. Otherwise, you have to face this 393 ppm. Clear? Now, do you understand what is CPCPK and PPPK? The same thing in another format. I will just show this in Minitab format, in Minitab, so that you will understand. So likewise, for any scenario, any kind of data, whether the data is about coating thickness or about diameter, you can certainly do the analysis, and just 2 minutes in Minitab will show you how you can actually conduct the case. So what I do is I will prefer to meet all of you for another 1 hour session to discuss with you the DOE, right? But the schedule has to be announced. I'll fix up a day and then let you know on that, because DOE is still pending. So I'm just showing the Excel file. All of you, can you see the Excel file? This Excel file I've already shared with you. Sigma level calculator. Hope everybody retains that. That contains a lot of data. So I want to refer to the data which I currently discussed with you. And file name should be coating thickness. Let me check. Can you see coating thickness, all of you?
Yeah.
Yeah. See here, the 75 data is available here. Coating thickness with roll number data. All the calculations manually I have done. You all can check and understand. Try to understand how the calculations are done manually. But right now, what I'm going to do is I'm just selecting the data points. Let me share with you the Minitab. You can see the Minitab screen now. I'm just pasting in here. Oh, sorry. Let me paste here in the gray bar. So coating thickness available in column 1 and roll number available in column 2. There are 75 data. So what I do is I just go to stat. I just go to quality tools. Can you see a capability analysis? Stat, quality tools, capability analysis, and choose normal. Can somebody read the description?
Determine how well your process output meets customer requirements when your data are reasonably normal.
Very good. I click that. And now where is my data? Data arranged in single column, which is C1. Double click. Subgroup size. Subgroup size is available in C2. Now your lower spec. What is your lower spec for the problem?
So 47.
47. And upper spec 53. You give this information and then give OK. And now it is throwing you the report. Can you see here, all of you? Same results, right? Can you see the report? The expected ppm is how much? Expected ppm is 394. Which side the rejections are more, LSL or USL? LSL. But currently, how many rejections on the LSL? No rejection. Can you see here? Currently, no rejection on the LSL. No rejection on the USL. Even though absolutely there are no rejection on the LSL, no rejection on the USL, still in the future, 293 on the LSL side is expected. 100 on the USL side is expected. All of you, do you understand how do we get this 293 and 100? Even though there is no rejection in the short term, it doesn't mean that in the long term also there won't be any rejection. Long term, there can be rejection. We are estimating that based on the tendency of shift and the tendency of variation. If the tendencies are low, then in the future also you will not have any rejection. So as I already told you, any process before doing the capability study, you must check for the control. So what kind of control chart I can plot here? X bar, R chart. So I am going for a X bar R chart. Where is my data? Data in single column. Where is that column? This is the column. Subgroup size is 3. And now I say OK. See here what happened? Now your report is... Come on, tell me. What happened? Your report is... Inaccurate, isn't it? So and moreover, please note, your specifications, your specifications are very high. That is the reason why, your rejections are expected to be low. So, but even then, you can definitely, improve the process further, and you can remove all these out of control points. So that is the message. That is the message. So that's how you should do it. Okay. So any questions, please ask.
Sir, in the last point, if we are saying that we remove those outliers or who are there, so that is approximately 25% of the existing data in this particular plot. So,
Correct.
I mean, we ourselves are just to remove the outliers at the cost of putting 25% of the data out. Aren't we actually, isn't it unethical?
Yeah, true. Definitely true. See, actually, outliers, you can't, just like that, you can't remove from your analysis. So instead, what you need to do is, you should find out the reason for the outlier in that particular point. Particular point is which particular day the samples are collected, right? And what are the conditions for that particular sample? Are there anything abnormally wrong? Can some action be taken? And can we identify the root cause? And then we have to fix it. This is the way, actually, each outlier leads to, requires some attention to the process. That's how we should do it. But for the sake of, some urgency, sometimes in business, we simply remove all the outlier and then perform the analysis just to see a healthier CP/CPK, right? But definitely now, even though we got a healthier CP/CPK, still our process, can be, what we understand from our control chart is, our process can be in a much more better state of control, which we fail to do it. So that is the gap we come to understand by looking at the control chart. So you establish better, control plan, and thereby you will get all the points going inside your control limit, and then you will be able to see much more healthier CP/CPK and PP/PPK. That is the point coming here. But right now, why our CP/CPK and PP/PPK are still higher? It is simply because of the wider tolerance given by the customer.
Can I add?
Yeah. Yes, sir. Please add.
In fact, that is what we do. That is, your gender does more, no? In real life. See, in a class, the average performance is, say, 60 to 70. We can improve the performance, right? By giving more attention to the students, giving more test and all. That is what we do, right? But there are persons who are naughty people, right? Then what do we do? The students who are very bad students, right, who create disturbance in my class, then what I will do? I will try to control those students only. Yes or no? And if I can't control those students, what will happen? How do I control? I will call their parents and ask them to be careful and do like that. If it doesn't help, what do? I send them out. I don't keep them in my class, right? Therefore, the outliers also, if you can manage it, bring them within your control, or else leave them out and then change the operator, or change the equipment, or change the raw material, whatever you do. The same way we are doing it, without knowing we are doing it. Now you have mastered it, you know that you are doing it. That's all. Our course is only telling you that, hey, this is what is happening, this is how it is happening, this is what we should do in everywhere. Thank you very much.
All right. I think you all now got the clarity, right? CP/CPK and PP/PPK. Perfect. Yes. So that means we can have a short break here, and then we can continue with the next session. So all of you, please come back sharp, after tea break, maybe 11:40. And you know what will happen? Accordingly, there'll be a 15 minutes stretch, during the lunch session. So we have planned up to 1. So that might go up to 1:15. So please come back after a short break, and then sharp 11:40, we are going to start again.